Does the integer k have 3 or more different positive prime factors? That is to say, can we say that k equals a times b times c times another integer where a, b, and c are all prime numbers? And the possibility exists that each of these prime factors may have its own exponent, right? A positive integer exponent. We are wondering if k is such a number that has at least 3 different prime factors. Let's see what we can get from statement 1. Statement 1 says that 3k over 15 equals an integer. If we simplify this expression, divide here by 3, get 1 by 3, 5. So we have that k over 5 is an integer. In other words, k equals 5 multiplied by some integer. It is possible that this number might be 30, which is exactly 2 times 6 times 3 times 5. So this would give an affirmative answer to the question, or it is possible that k is just 5, giving a negative answer to the question. Statement 1 alone is not sufficient. Let's try statement 2. If 4k over 9 is an integer, we can reason like this. 4 is not divisible by 9. So for this quotient to be an integer, k must be divisible by 9. In other words, k needs to be 9 or 3 squared multiplied by some integer. But this gives you the possibility to have, for example, k equal to 90, which is a number that has 3 different prime factors, affirmative answer, or k might simply be 9. And of course, this would be a negative answer. So statement 2 alone is not sufficient either. What do we know from statements 1 and 2 together? On one hand, we have that k is a multiple of 5. And on the other hand, we have that k is a multiple of 9. From these two facts together, the only thing I can gather is that k must be divisible by the least common multiple of these two numbers. In other words, k should be 45 times some other integer. If k equals, for example, just 45, then the answer is negative. But let's say that this number, k, is 450. Then 450 has actually 3 prime factors, right? Because 450 is 3 squared times 5 squared times 2. So yes and no, not sufficient. The correct answer choice, 2 statements together are not sufficient.